So welcome back to our channel. So today we are going to teach you about metals and non-metals. So let us start with the composition. There are 118 known elements, and out of that 93 are metals, 18 are non-metals, and 7 are metalloids. We will be briefly discussing about that in the next slide. All the elements present on this earth are classified into three types: metals, metalloids, and non-metals. As you can see in this table, magnesium and mercury are metals, whereas oxygen is a non-metal. So what are metals? Metals are elements whose atoms readily lose electrons to form positive ions, that is cations, except hydrogen, which can either lose or gain electrons. Metals are electropositive elements as they form positive ions by losing, that is donating electrons. Here are some examples. Aluminium, and the symbol of aluminium is Al. Calcium and its symbol is Ca. Sodium and its symbol is Na. Potassium and its symbol is Ka. Magnesium Mg. Copper Cu. Zinc Zn. Lead Pb. Iron Fe. So aluminium is the most abundant metal, constituting 8% of the Earth's crust, while iron is the second most abundant metal, constituting 5% of the Earth's crust. Our next topic is nonmetals. So nonmetals are elements whose atoms readily gain electrons to form negative ions, that is anions. Nonmetals are electronegative elements as they form negative ions by gaining electrons. Example: carbon and its symbol is C, nitrogen N, oxygen O, phosphorus P, and sulfur S. So oxygen is the most abundant nonmetal in Earth's crust that makes about 46.6% by mass of Earth's crust, followed by silicon, which is the second most abundant nonmetal that forms about 27.7% by mass of Earth's crust. So next we have alloys. An alloy is an admixture of metals or a metal combined with one or more other elements. For example, combining the metallic elements gold and copper produces red gold, gold and silver becomes white gold, and silver combined with copper produces sterling silver. Combining iron with non-metallic carbon or silicon produces alloys called steel or silicon steel. The resulting mixture forms a substance with properties that often differ from those of the pure metals, such as increased strength or hardness. Bronze is an alloy of copper and tin, whereas brass is an alloy of copper and zinc. Our next topic is metalloids. A metalloid is a type of chemical element which has a preponderance of properties in between or that are a mixture of those of metals and nonmetals. So basically a metalloid is a type of an element which has properties similar to both metals as well as nonmetals. The seven commonly recognized metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. So let us differentiate metals and nonmetals based on its physical state. Let's start with metals. So metals are solid at room temperature. Example: iron, copper, aluminium, etc. An exception is mercury, which is liquid at room temperature, sodium and potassium, which are soft metals. Next, nonmetals. Nonmetals may be solid, liquid, or gaseous at room temperature. Out of the 18 nonmetals, 6 nonmetals are solid, 11 are gases, and 1, which is bromine, is liquid at room temperature. Next, we have thermal and electrical conductivity. The ability of a material to conduct heat and electricity is called thermal and electrical conductivity, respectively. So, for conducting heat, it is called thermal conductivity, and for conducting electricity, it is called electrical conductivity. So, metals. Metals are good conductors of heat and electricity. Examples: copper vessels. Exception: mercury and lead, which are poor conductors of heat. Non-metals do not conduct heat and electricity. Exception: diamond is a good conductor of heat. Graphite is a good conductor of electricity. Next we have malleability. The property of elements by which they can be beaten into thin sheets without breaking is called malleability. Metals are malleable. Example: aluminium, foils, gold, etc. An exception is mercury. Non-metals, whereas, are not malleable. Example, sulfur. As you can see in this picture, gold is beaten and it is converted into thin coins. Next we have ductility. The property of elements by which they can be drawn into thin wires is called ductility. Metals are ductile. Examples, silver chain, cable wire which is made up of copper. An exception is mercury. Whereas non-metals are not ductile. Example, sulfur and arsenic. Gold is the most ductile as 1 gram of gold can be used to draw a wire of length of 2 kilometers. We have some extra properties. So metals are sonorous, that is capable of producing a ringing sound when hit by an object, whereas non-metals are not. Metals are hard and strong, exception mercury, sodium and potassium. Non-metals are generally soft, exception is diamond, which is the hardest naturally occurring substance on earth. Next, metals have luster, that is a shiny appearance, whereas non-metals are non-lustrous. We have some exception, that is graphite and iodine. Next we have is the reactivity series. Metals, according to their reactivity, are arranged in a specific arrangement in order of their decreasing reactivity, which is termed as reactivity series of metals. In the reactivity series, the most reactive metal is potassium, which is placed at the top of series, while platinum is the least reactive metal, which is placed at the bottom of the series. So all elements above hydrogen are highly reactive metals, whereas all elements below hydrogen are less reactive metals. Our next and the most important topic is displacement reaction. So, displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. Both metals and non-metals take part in displacement reactions. Example, when an iron nail is placed in the blue colored aqueous solution of copper sulfate, after some time it is found that the intensity of the blue color of the solution slowly decreases and iron nail becomes brownish in color due to deposition of copper. So the chemical reaction is copper sulfate plus iron, which will give iron sulfate plus copper. Next, we are going to differentiate metals and non-metals based on their chemical properties. First, metallic oxides are basic in nature, whereas non-metallic oxides are acidic in nature. Sodium, when it's heated in the presence of oxygen, produces sodium oxide, that is Na2O, which is basic in nature, whereas carbon reacts with oxygen to form carbon dioxide, which is acidic in nature. Some highly reactive metals react with water. Example, potassium, when it reacts with water, forms potassium hydroxide and releases hydrogen gas, whereas non-metals do not react with water at all. In case of sodium and potassium, the reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. Calcium and magnesium metals floats on water because bubbles of hydrogen gas formed during reaction with water sticks to the surface of calcium and it floats over water. Next we have corrosion. So what is corrosion? Degradation of metals in contact with air or moisture is called corrosion. When a copper vessel is exposed to moist air for long, it acquires a dull green coating. The green material is a mixture of copper hydroxide, which is CuOH2, and copper carbonate, CuCO3. Corrosion of iron is called rusting of iron. Iron gets oxidized into iron oxide under the action of oxygen present in the atmosphere. Gold and platinum do not react at all with air and are therefore called noble metals. Next we have the uses of metals and non-metals. So metals and non-metals are used in bioprocesses. Example, iron is a constituent of hemoglobin, which is essential for oxygen transportation. Oxygen and carbon dioxide are the gases for our life, which is very important for respiration. Then in goods and machines, copper and aluminium are used for making electrical wires and cables. Sulfur is used in batteries, detergents, matches, gunpowder, etc. In health, mercury is used in thermometers, sphygmomanometers, etc. Sulfur is used as a fungicide. Hydrogen is the most efficient fuel. Over the period of time, coin has been used for monetary transaction. Silver, gold, copper, etc. have been used for making coins and are therefore they are called as coinage metals. Now we come to the end of this topic. Hope you have enjoyed. Please like and subscribe and press the bell notification for the latest update on our channel. Thank you.